Welcome to Study Loop.
Hello there. We have this reaction given that looks like this. We have a neutron that collides with a boron target, and we have a lithium that is formed and an alpha particle. What this problem asks is that if everything is stationary and has no initial kinetic energy, what is the speed if the only thing that is given energy is the alpha particle out? So what we need to do is we need to see what the difference is for each of these isotopes, and then we can determine what the speed is of the alpha particle. All right, so what's going to be important here is realizing that each of these isotopes can be written in terms of this value U, which represents a type of bond energy. U is 931.5 MeV, and we'll just deal in terms of rest energy. Okay, so for this neutron, we have that this is 1.0 866 U plus 10.01294 for the boron. All right, now what I'm going to do is I'm going to subtract lithium over onto this side so that we're left with just the total energy of the alpha particle on the right, minus 7.016 U, and that's going to be equal to the total amount of energy the helium has. So essentially what I'm saying is this is the energy we start with minus this lithium energy, and that will give us what's left over for the alpha particle. It's just an algebraic relationship, and we're left with 4.0056 U. All right, now the way this is going to work is my energy relationship, that total energy is equal to this factor gamma times the rest energy, where gamma is equal to 1 divided by the square root of 1 minus U squared over C squared, where U is the velocity of the alpha particle. So let's go ahead and look at this. So my total energy for the alpha particle is this 4.0056 U. So I'm going to solve for what gamma is first. So from this equation here, I can say that, okay, gamma then is going to be equal to the ratio of energies between what its energy is divided by its rest energy. Okay, so when I calculate this energy here, I get that this is 3,731.2 MeV. All right, now the rest energy for this is going to be 4.0026 U. I want to multiply that by 931. I'll get a value on the bottom. And what I get is that actually we are very, very close to the rest energy, but not quite at rest energy. So this is almost exactly a unity, but not quite. So we are going to have quite a velocity on this particle. Okay, so now that we know what gamma is equal to 1.00075, and I can set that equal to my other expression. And I can do some algebraic manipulation. First thing I'm going to do is divide both sides by this quantity on the left and multiply both sides by this quantity here on the right. All right, what I'm left with is that 1 over 1.00075 is equal to the square root of 1 minus u squared over c squared. And I can solve this for u. And what I get for u, let's put it over here. U is equal to square root of 1 minus that quantity, 1 over 1.12375 squared. Okay. And that is times c. What I get is that the alpha particle is about 4% the speed of light, or 1.16 times 10 to the 7th meters per second. All right, that should do it. Thank you, guys.